So here we are with a very interesting concept called as ratio and scale. What is a ratio is something that we have seen before. Now today we will see what is the connection of ratio with scale. This scale does not mean the scale that we use to draw a straight line. But this scale is the scale that we see whenever we see any kind of a map. If you want to check, you can go on to Google and you can check any map, literally any map. So at the bottom, either left hand side bottom or the right hand side bottom of that Google map will be written scale, and then it will be 1 is to 5,000, 1 is to 10,000, 1 is to 3,000, something. It means that 1 centimeter on the map. So I'm showing in the map, I'm showing that Mumbai is somewhere here and Delhi is somewhere here. The distance between them is approximately 5 centimeters. And the distance between Mumbai and Delhi is approximately 2000 kilometers. So 5 centimeters is showing 2000 kilometers. So what we'll do is we'll convert this kilometer into centimeter first. So we'll write 5 centimeters is equal to 2000. Kilometer into centimeter will be first 1000 meter and then centimeter. So 5 centimeter is equal to 1, 2, 3, 4, 5, 6 and then 20 meter. So we get 1 centimeter is equal to, we divide by 5, we get 4, 1, 2, 3, 4, 5, 6, 7. So then our scale becomes 1 is to 4 and then 7 zeros. So this is, I think this is 4 crore. So 1 is to 4 crore or 1 is to 40 million is the scale. What it means is what you have on the map, every centimeter represents these many centimeters, and then you can convert it to meter kilometer. But when we write scale, we are using the same units because the ratio is basically used between quantities of similar units. Then it is further generalized and then you can use different units as well. But basically you keep the unit same. So what is there in the scale is based on this logic. Supposedly on a scale, if in a map the scale is 1 is to 500, it means that the map is so zoomed in that 1 centimeter that you see on the map is basically equal to 500 centimeters. So 1 centimeter will be equal to 5. This is how when you completely zoom in, you get a map of this scale. But then the maps, different maps will have different scales, and appropriately we are going to solve some problems. Let us see the problem based on this. Expressing the ratio in the form of 1 is to n. So all the scales must be either expressed in the form of 1 is to n or n is to 1. Why 1 is to n and n is to 1? So if we are if the map, if you are talking about a geographical area which was very large and we are representing by shortening its distances, like the world map or like the map of a city or like even the map of a school or a residential colony, then we are drawing it on a piece of paper or we are seeing it on a computer screen. This entire screen is far smaller in comparison with the entire society or the entire building. So what we are doing is, here 1 centimeter will be equivalent to far greater value. So maybe it is 500 or 5,000 centimeter. 5,000 centimeter is 50 meters. So what was 50 meters is shown to be only 1 centimeter in the diagram. So that there the ratio will be 1 is to 5,000. But the opposite that can happen is n is to 1. When will that happen? Supposing you are taking the photograph by zooming in. You have a very specific design camera, and with that camera you are taking the pictures of maybe you have a picture of a cell. Now what is inside a cell is so small and you magnified it so big, so large, and then you see the universe. So what is seen to be 10 centimeters is actually equivalent to only 0.01 centimeter. So you divide by 10, you get 1 centimeter is equal to 0.001 centimeter. So the ratio is 1 is to 0.001. We don't keep it like that. So we'll multiply both by 1000, so we get 1000 is to 1. Or if you want like this, we can convert this like this as well. And we will get 10 centimeter to 0.01 meter. So 10 centimeter is equal to 1 upon 100 centimeter. Then you multiply by 100, so you get 1000 centimeter is equal to 1 centimeter, and the ratio is 1000 is to 1. If you are talking about a large area and you are shrinking it to fit the screen, then the ratio comes out to be 1 is to n. If you are talking about a very small object and you are expanding and enlarging it so that you can fit it onto the screen, the area comes out to be n is to 1. There are only two kinds of scales which are possible, 1 is to n or n is to 1. If it comes out to be fraction, if no complete division is not possible, it's fine, but still you write it as 1 is to 1 and n is to 1. Either of this or this. Now let's see some problems. Let's see this work example. Express 5 is to 1000 in the form of 1 is to n. This is so simple that it's almost shameful for us to solve this. 5 is to 1000 is equal to, now we'll divide both of them by 5 because 5 is a common factor. And we want to convert it to 1 here. So anyway we have to divide by 5. So we'll convert this 5 has to go and become 1. So divide by 5, 5 upon 5, 1000 upon 5. It is 1 is to 1. Similarly here, 4 millimeter is to 50 centimeter as a scale ratio. Let's solve it here. So we have 4 mm is to 50 cm. We'll keep the unit same first. So we get 4 mm is to 500 mm. 1 centimeter is 10 millimeter, so 50 cm is 500 mm. And then we divide by 5. So 1 mm is to 125 mm. So the ratio comes out to 1 is to 125. And diagram. We'll see some problems now. Let's see the exercise. Yeah, let's see the exercise. Exercise. Write each of the following scales as a ratio in the form of either 1 is to n or n is to 1. Very simple. 1 centimeter to 2 meter convert into the same unit. 1 centimeter is to 200 meter. So this will be 1 cm is to 200 cm. So this is 1 is to 2 centimeter is to 5 meter. 2 centimeter is to 5 meter. 5 meter is 500 centimeter. So this is 1 centimeter is to 250 centimeter. And the ratio comes out to 1 is to 250. So all of them can be converted just very simple. Here you also watch out 9 mm is to 150 kilometer km. Now km has to be converted to mm. Now to convert that, you have to first convert it to meter, and then meter has to be converted to millimeter. How do you convert kilometer to meter? You multiply by 1000, and then meter to millimeter again multiply by 1000. So this basically will be 9 mm is to 150 into 10 raised to 6 mm, and then divide by 9 and you get the answers. Let's see this scale diagram of a shopping center is drawn to the scale 1 is to 400. Find the real distance in meters of the following lines measured on the diagram. So what is being given here is there was some shopping center and it is being drawn on a piece of paper. So this is the plot for the shopping center, and the plot is drawn to the scale. But it is obvious you cannot have the entire shopping center fitting onto a piece of paper. So you have to reduce the size of it. You have to shrink it, but you shrink it proportionally. So how are you going to do that? It was agreed that everything will be divided by 400. So if the length of the plot was 400 meter, we will show it to be only 1 meter. If the length of the plot was 40 meter, we will show it to be 0.1 meter or 10 centimeter. That's how we are reducing it. That's the scale reduction that is key. Now, if the length of the plot is coming here, something, let's say this is the parking area, and inside the parking area there is a small cubicle in which the security guards will sit. Maybe 3-4 guards will be there at one point of time. Now the cubicle will have a length equal to 1 centimeter on the map. On the diagram that we are doing, this is 1 centimeter. We are asked to find out what will be the effective size of this cubicle if this is 1 centimeter by 1 centimeter on the map that we are doing. This is not a map, on the plan that we are doing. So how do we do this? The scale is 1:400. So what is 1 centimeter on the diagram will be equal to 400 centimeter in the real. Now you divide by 100 to get it into meter, because we are asked for measure the following length in meters. So to get it in meter, we divide. So 1 centimeter is equivalent to 4 meter, and that's it. So this is 4 meter by 4 meter in which the security guard will be sitting. That is what the first question is. Now 15 millimeter, it's very easy. Again, we convert this 1:400. So we multiply this with 15 here, so we get 15 is to 15 into 400. So this is 6,000. And this is in millimeter. This 6,000 is also in millimeter. 6,000 millimeter is 600 centimeter. 600 centimeter is 6 meter. So this is basically 6 meter. So the answer for this is 6 meter. If 1 centimeter was 4 meter, 15 mm is 1.5 centimeter. So 1.5 times of this will be 1.5 times of this will be 6 meter. And this is 3.5 centimeter, which is 3.5 times of this. So 3.5 into 4, which will be 14 effective. You will get the answer 14. Just follow the same steps. Then for 12 centimeter, you will just get 12 into 4, that is 48. You can just follow the steps and you get the answer. Let's see the next question. A map has scale of 1:50,000. How long will each of these real legs be on the map? So the real length on the map is 60 centimeters. So the real length is 60 centimeter, and we are asked if the real length is 60 centimeter. On the map it will be how much? So it's 60 meter, and on the map it will be how much? So the map is 1:50,000. So what was 50,000 centimeter would be 1 centimeter on the map. So 1 on 50,000 is equal to, let's say on the map it is x centimeter divided by 60 meter, and we find the value of x. What we are seeing is this is equal to the distance on the map divided by actual length. The ratio are equivalent ratios, and because they are equivalent ratios, you can just cross multiply to get the answer, or you just multiply by 60 here. 60 divided by 50,000 is equal to x. 60 is in meter. 1,0,1,0,1. 6 upon 5 is 1.2 upon 1,000 meter is equal to x. 1 upon 1,000 meter is 1 millimeter. If you don't know, you can convert this meter into centimeter and then millimeter. You will get the answer. This is what the value of x will be. So this distance of 60 meter will be shown on the map with a distance of 1.2 mm. 15 kilometer. Let's say 15 kilometer. So if the map scale is 1 is to 50,000, this is the real distance. This is the distance on the map. And we'll say that we'll take this as a ratio 50,000 is equal to the distance y on the map divided by real distance of 15 kilometer. Some students ask me, sir, how can we identify if these distances given are the real life distances or distances on the map? There are two answers to that and both are very obvious. See, it is already given how long will each of these real lengths. That's the first part. Second part of it is if you use your sensibility, you will know that 15 kilometer cannot be drawn on the map. Has to be real length. Even 60 meter you cannot draw on the map. Has to be on the real length. So then everything is resolved. It's just a matter of getting the answer. So this cross multiply we have y is equal to 15 kilometer, which is 15,000 meter, divided by 50,000. 3 upon 50 is 0.3 meter, which is either 20 centimeter or you can say that 0.3 meter, which is fine. Accordingly, you can get the next questions. Let's see the next problems. Question number 4 is saying that a rectangular hall is 20 meter long and 50 meter wide. Draw a scale diagram for this hall using a scale of 1 to 200 and the second is 4 mm to 1 meter. Now, how can we imagine a hall that is 20 meter long and 50 meter wide? Imagine this is a marriage hall. People build these kind of halls and give on rent. Or there is some kind of felicitation program going on there. Community hall are usually this big in size. So 20 meter by 50 meter. In this case, we are interested in drawing the scale, drawing this diagram with a scale of 1 is to 200. So we will convert this into the appropriate scale. So we will say let the diagram have dimensions of x and y, and purposefully I am writing centimeter here because I don't want to leave any confusion with this. I want this in centimeter. So 1 upon 200 is the scale, must be equal to x centimeter upon 20 meter. I am writing the units here. We will first have to make the same units. So 1 upon 200 is equal to x centimeter upon 2000 centimeter. It's very simple. Just convert this. You want to make the same denominator? Multiply this by 10. 10 upon 200 is equal to x upon 2000. The fractions are equivalent. The denominators are same. Numerator has to be equal. X is equal to 10 in centimeter. Y in centimeter, we started with centimeter. Similarly, you can find the value of y. If the x is coming as 10 centimeter, then the value of y will be, I think, 25 centimeter. So this is 2.5 times. So this will be 2.5 times 10 centimeter. You will get the answer. If you do the p part of it, 4 mm to 1 meter. So this now. New scale 4 mm divided by 1 meter is equal to x centimeter divided by 20 meter. Now without any exception, just convert everything into the same units. I'm not saying that this has to be converted to meter, but these two units must be equal and these two units must be equal, so that the units will cancel each other. So we'll get 4 mm. 1 meter is 100 centimeter. 100 centimeter replace 1000 mm. So divided by 1000 mm is equal to x cm upon 2000 cm. cm cancels, mm cancels. Let's not hurry. Let's just take 4 upon 1000 is equal to x upon 2000. This is 2000 here. Make 2000 here. Multiply by 2. So we have 8 upon 2000 is equal to x upon 2000. So x must be equal to 8. The logic is if this was the scale, then the distance of 20 meters would have been represented by an angle of 8 centimeters. Why centimeter? Because we had started with centimeter division. And the distance y will be, because it is 2.5 times this, it will be 2.5 into it will be, I think 20 centimeters. You can calculate by saying y upon 50 here and then you get the value. This is a good question, question number 5. An insect drawing at a scale of 5:1 is 2.75 centimeters. What is the actual length of the insect in millimeters? Let's go. So we are drawing an insect. You know the insects are very small. The insect is drawn with a scale of 5:1. So 5 upon 1 is equal to, on paper, it is 2.75. So what are we doing is, whatever be the size of the insect, we are magnifying it 5 times. So 5:1 is the scale. So whatever be the size of the insect, it is 2.75 divided by its size on the paper will be, am I right on this 1 second. Then insect drawn at a scale of 5:1 is 2.75. Let's see. What it says is, on the drawing, when you are drawing, and when you are drawing it with a scale of 5:1,